Okay, 8th graders. Well, we kind of wrapped up chapter 5 last week. I know some of you weren't the most excited about how that test went. Don't stress about it too much. We are moving on. We are going to be doing, this is basically chapter 6 from your textbook, so if you want to use the book to reference, you certainly can. But this is a unit separate of our text, okay? So we are going to be talking about systems of equations. We're going to use lots of the skills we learned from chapter 5. So for today, we're just going to go through the first 2 pages, and then you guys will have just a little homework assignment. So a system of equations is a collection of 2 or more equations with the same variables. So these are 2 equations. They both have x and y. The solution is an ordered pair that satisfies both equations. And that's really important that it makes both true. So when they say satisfies, it means makes both equations true. Okay, so the solution to the system above is 2, 3. Let's prove it. So they took the first equation, 4x minus 5y equals negative 7. They put the x and the y into the equation. 4 times 2 is 8, minus 5 times 3 is 15. 8 minus 15 equals negative 7. Negative 7 equals negative 7, so it's true. Okay, again. This equation here is y, which is 3, x plus 1. Okay, so our x is 2. Does 3 equal 2 plus 1 is 3? So it's true. So it has to make both equations true in order for it to satisfy the system. Okay, so it says the system above is a system of linear equations since both equations are linear. So chapter 5 was all about linear equations, linear functions. There is not always a solution to a system of linear equations, but when there is, it is the only solution in the universe. That's surprising at first because the equation 4x minus 5y equals negative 7 has infinitely many ordered pairs, solutions. And then the other equation has infinitely many ordered pairs. But when you put those 2 lines together, there could only be one answer, which is kind of cool. Okay. The other thing that I want you to know is that this answer is the point at which these 2 lines cross each other. Okay, and we'll go into that more on Wednesday. Actually, nope, I don't think we hit it today. So now the first step is just to prove if the following ordered pairs are solutions. So remember, x, y. You're going to put them into the problem. So 2y equals 3x minus 1. And I'll do my other one, x plus y equals 7. 2 times y, so it's 2 times 7 equals 3 times x, which is 5. 2 times 7 is 14. 3 times 5 is 15. 15 minus 1, does 14 equal 14? Yes, so the first equation is true. What about the next equation? So if I put the 5 in for the x and the 7 in for the y, does 5 plus 7, which is 12, does 12 equal 7? No. So this one was true. The second one was false. So is this a solution? No. Okay, next one. 5, it doesn't matter if they use different letters as long as they are the same. So 5 times 2 plus 2 times 4. I'm getting these right from here. 5 times 2 is 10, plus 2 times 4 is 8. 10 plus 8 equals 18. Does 18 equal 3? No. So this is false. If this one is false, do I have to even do the other one? No. Because they both have to be true. Okay. So there were 2 no's. So now let's go over here. We'll test this one. X, Y. We're using these right here. So 2y equals 3x minus 1. The other one is x plus y equals 7. 2 times 4 equals 3 times 3 minus 1. 2 times 4 is 8. 3 times 3 is 9. 9 minus 1, does 8 equal 8? It does, so this one was true. Now, 3 plus 4, does that equal 7? Yes, 7 equals 7. So this one is also true. Both equations came out true. So the answer is yes. Okay, last one here. 5c plus 2d equals 3. The other one was 3c equals 1 minus d. My c was a -1. My d was a 4. This gives me -5 plus 8 equals 3. -5 plus 8 does indeed equal 3, so this one's true. The next one over here, 3 times -1 equals 1 minus 4. 3 times -1 is -3. 1 minus 4 is -3. So again, this is true. So if they are both true, then this is a yes. I made it a solution. So that's the first page. Okay. So you will eventually learn that at least 3 methods, there are 3 methods for solving systems. Until you do, we are just going to do a little guessing and checking. So we're going to have some word problems. So John is thinking of 2 numbers. Their sum is 17, so x plus y, those are the 2 numbers, is 17. Their difference, so if you take and subtract the 2, you get 5. This situation is represented by this system. Which 2 numbers is he thinking about? So when they say guessing and checking, you just want to think, well, what plus what gives you 17? Okay, so if I did an 8 and a 9, that gives me a 17. What about 11 and 6? You could do 13 and 4. I mean, you can come up with some different ones. But see, the difference has to be 5. So 9 minus 8 is 1. 13 minus 4 is 9. What about 11 minus 6? Does that give you 5? It does. Make sure you put them in the right order. Okay. So the next one, Rachel is twice as old as her younger brother, Andrew. So I like to use the same letters if I can, so Rachel and Andrew. So Rachel equals twice Andrew's age. The sum of their ages is 18. So if you take Rachel plus Andrew, you'd get 18. So what plus what would give you 18? Like you can guess and check here. So like, for example, I think of 12 and 6, right? Rachel is twice, equals twice Andrew's age. 2 times 6 gives you 12. Does that work? It does. So you guys are probably going to be pretty good at guessing these. Coming up with the equations kind of comes with a little bit of practice. Okay, the next 2 are weird. You will need to remember these systems throughout this unit. Okay, so if you have x plus y and it equals 10, and you have x plus y and it equals 11, can that happen? And the answer is no. So what if x was 6? 6 plus 4, does that equal 10? We'll put those numbers here. Does 6 plus 4 equal 11? No. So this cannot happen, which means that it is a no solution. Okay. Now here though, if you take and subtract x and y, and you both get the same answer, that is true. So what this means is that there's infinitely many solutions. So let's just practice looking at these different types. So same on the left-hand side, can they equal two different things? No. So this is a no solution. Same on the left, can they equal two different things? No solution. Now here, this one's a little bit trickier, okay? And you guys haven't done this very much, but you can factor something out. So they all three can be divided by 3. So if you divide this one by 3, you get x. If you divide this one by 3, you get a -2. And if you divide 18 by 3, you get 6. Are these the same? And if they are, this is the infinitely many solutions. Okay. Same thing. They match on this side. So, and they both equal -9. Infinitely many solutions. Now here, you want to check. You can factor something out. So I can divide all of these by a 2. 2 divided by 2 is just a 1x. 2 divided by 2 is 2y. And 16 divided by 2 is 8. Do these match? Yes. And then the last one, they are the same on the left-hand side, but they are not the same on the right-hand side. So these are no solutions. Okay, and that's it for your notes today. I am going to have you guys do the Intro to Systems of Equations homework. I want you guys to work on this. And there is the back side. But please stop. Don't go on to the next one. So just do the Intro to Systems homework. Shoot me questions if you have them so I can help you. You can take pictures. You can tell me I need help with number 4 from the packet, however you want to do it. But let me know if you guys need help. Have a great day.